like give me a look and be like, simmer, dude. But like, yeah, I'm at like 50%. I went to the doctor. I'm not contagious. If you are sick, don't come to school. But that's why I wasn't here Monday. So typo on your homework. On your homework paper, because when I copied things over for formatting, your 5.2, is it on 5.2.3? 5.2.3, and now my Adobe doesn't work, so I have to do this. Says 12, because the formatting got dropped. Change that 12, like cross it out, change it on your paper right now. It should be 1/2. The formatting, when I copy pasted, because like you could just be doing homework out of a textbook. I don't know how many of you would like to take a textbook home with you every night, or have to get on the Chromebook, which honestly I'm tired of using Chromebooks. I don't know about you guys, but after a quarter of it, I'm tired. If you're doing your homework, stop and go and change the typo on 47. I can tell from body language who is not paying attention. This, I don't think, is solvable if it's 12x. Well, it's probably solvable, but it's a negative intersection point. So you'll make your life a lot harder if you don't pay attention to change that typo. And now we have some well-loved animals, right? So, this is not Miss Hassanin's cat, but we can, what's her cat's name? Oh, come on, she hasn't talked about him that much yet?
No.
Kiwi, thank you. So, I'm going to call this bunny Bugs, just for fun. So, we got Bugs and Kiwi. Bugs is currently 5 pounds. And he is gaining 3 pounds per year. It's on your paper.
Yeah,
Read with me. And Kiwi is currently 19. I don't know who has a cat here, but I feel like that's kind of heavy. Like my new dog is 30 pounds right now, so. I mean, but she's still a puppy. She's gonna be like 50. Yeah. So like Caroline's cat is 8 pounds. So either way, no judgment. Everyone's body type is your own choice. So we need to figure out when will they have equal weights. So on your paper, we're not going to graph these. We're not going to set up any y-intercept and slope and whatever. However, we do want to first figure out the equations of their lines. Now, if you're not certain about how to figure out that equation of the line, I might as well just do it on your paper because I like my formatting better. And with all the people that we have sick today. Whenever we have something that's happening over and over again, but we don't know how many times it happens, what could we use to represent the how many times it happens? X, right? So, okay, well, I called it Barbara has a bunny. Okay, I didn't call the bunny Barbara. But if it currently weighs 5 and is gaining 3 pounds per year, here's Bugs. It's currently 5. It's gaining 3 pounds per year. Now, we don't quite know what this little diagram means yet because we haven't jumped back into CPM for too long. But I think you guys can figure out it's showing us 3x plus 5. So we could write down, okay, Bugs' weight is going to be 3x, or you could say 5 plus 3x, right? Because it's starting at 5. It's gaining 3 every year. If your pencil is not in your hand, I do not know why. What about Kiwi? What equation could we write for Kiwi? I'll put C of X for cat, even though Kiwi is spelled with a K. Madeline? Yeah, we could just do 1x because it's 1 per year. We want to know when will those two animals, after how many years, right? Isn't it years, not months? Yeah. After how many years will they weigh the same thing? Chat with your partner about how we can solve this. I showed you this method once at least last week. It's called the equal equal values method. That is not how we're going to do it. That is a whole lot of work. That is one way we can do it. Don't erase it. But there's a much easier way to do it. We want to know when those two animals will be equal. When will those two animals be equal? So there's not only is this what we're doing right now, because you're looking on your homework, this is the paper that we're working on. This is so is there a reason that after multiple times if you ask them, please stop doing your homework, you were still trying to do your homework? I cannot understand. Stop. You made a mistake. Are you doing what you should have made at home? You had all the correct papers. We want to know when they will be equal. What we're asking is when... Well, actually, I shouldn't be telling you guys. I should be asking you guys. What could we do here? What are we essentially trying to set up? Aren't you? Yeah, when will B equal C? When will this equal this? So couldn't we just set up 3x plus 5 equal to 1x plus 19? Make them, force it. Here's what we want. We want them equal. Force it to happen. Set them up equal. Now we just have to say, well, what x makes this happen? Do not just guess and check. Do not just make a table that'll take you like a day, well, not a day to figure out I'm being dramatic. What? Wrong class. Caroline, what could I do now that I've got these equal to each other? We could, but I will advise you start by thinking about your x's. So Caroline, what you're doing is exactly what I'm going to do next. But I would always tell you start with your x's. Take away the smaller x amount. Guys, we're going to draw this over here. What we're going to do is take away x from both sides. We're going to take away an x from both sides of this diagram that we set up. Minus 1x, minus 1x. Now we have still 2 x's left. We still have that plus 5. Now that x is gone, and we still have 19. So I would ask somebody else, but Caroline already said it. What do we want to do now? Minus 5. I'm going to change colors just for fun. All 5 of these. And it's a little bit harder to grab 5 of these. So 2x equal to 14. Anybody, what are we then going to do? Divide by 2 on both sides. And x equals how long?
7.
Now wait. How heavy will they be? How can I figure out? Because now I know 7 years. Right? I know 7 years. How do we then figure out how heavy they are, Kyrie? Take your 7 up into either of the previous equations. Now, I could do both because they should come out to be equal to each other. But I really only need to do one of them because I said these values will be equal here. So when x, what's 7 plus 19? 26. What's 3 times 7? 21 plus 5? Oh. So our solution here is 726. 7 years, 26 pounds, and 2, in my opinion, unhealthy weighted animals. Questions on how we solved that one? Should I get it on both sides?
Yes.
Yes.
I got Evo with that one. Well, this one already has this. I got my flu shot yesterday and it hurt because I was at the doctor and they're like, "Oh, you work with kids. You want a flu shot? Here it is." Like they barely they want everyone. I didn't get like a COVID booster because there's some contention on that. And honestly, I'm more worried about the flu than I am COVID at this point. Lydia,
So what I did is I just did the subtract 5 from both sides and then ended up
you
working out 5.
can do that first. I'm just telling you the safer route. Think about your x's first because you want to leave your x's on the bigger side. But if your x's ended up over here, you'd still get the same solution.
I was just asking why it was safer.
Because it's easier to work with positive x's. So let's play this out. I love the what if. You guys can always ask the what if or the why. Let's play this out. Don't write this down because this is the more difficult route. If I am silly, none of you are as silly as me probably. If I'm silly and I subtract 19 first, just because, I want to get rid of it just because. I have 3x minus 14 equals 1x. Well, then my x's feel like they need to come over here. So minus 3x. So now I have negative 19 equal to negative 2. I'm working with a bunch of negatives now. As opposed to, that's 14, not 19. I just can't read my own handwriting. Some of you can't read your own handwriting. If I divide by negative 2, I have to remember a negative divided by a negative makes a positive. I have to remember to get rid of these negatives. It's just easier to keep things positive, which is why we think about the x's first.
So it would have worked really well in this case scenario, but not in others kind of thing.
I'm saying in every... Let's do a few more examples. You'll start to believe me the more you work with these.
I subtracted the 5 and never got a negative.
I know, because if you start by subtracting 5, that is fine. Here, that worked out because still, you're arguing the wrong thing.
Okay.
We still subtracted 5 here. I have no issue with subtracting 5. What I'm saying is in any equation solving, if you deal with the x's first and try to keep your x's positive, it will be easier. You can do whatever you want. You can work with negatives if you feel like it, but you'll get the same answer. All right, on graph paper, because we always need graph paper, we're going to figure out this problem, but I'm not going to do anything for you. So notice how on your start slide, it said that graph paper is always necessary. No, it didn't. I didn't copy that over from last week. Graph paper isn't always necessary. I shouldn't have to put it up here. We're always going to use graph paper.
I have an entire
You
binder.
can continue it day after day after day. It doesn't have to be 1 page per day.
I have an entire binder full of
graph paper. It's beautiful. Carter.
I'm gonna let you guys take care of it. I bet we need less than 5 minutes. So I'm gonna set this timer and hope we're done before then. This is not on your paper. It's going on graph paper. You need to read this and talk with your partner about how to set it up, how to solve it. I'm going to give you a head start, and then maybe I'll highlight some things. We should not use graph paper. We're going to use our chubby bunny kitty method.
What? I didn't hear you.
We don't need those right now. Well, we don't need those notes pulled up right now.
So medium and then one line. Okay. So let's write a line that represents Richmond High School. Population.
So we could do like P of X for post falls. Do like P of X. Do R of X for Richmond. Right? They said we don't have to just do Y equals. We can do function notation. This is really special. When will they have equal population? And what will their population be? So we need to be using function notation. You can be ignoring me right now if you're really confident in what you're doing. So we need to write out what it is we are talking about. If I'm talking about post falls, don't just use Y. Indicate that you're talking about post falls, P of X. We're pretty much always going to use X unless you just decide to go rogue and use a different variable. But Eva, what can I write about post falls? How can I put that as an equation?
You could do 11.
You're fine, 1160. We can say it that way.
1160 plus 22x.
Because 22 students per year is a growth. So that's where we get our 22x. Dave is apparently possessing my smartboard today and not letting me write like every 5th time I touch the board. Madeline, what about Richmond High? Yeah, negative 15x plus 1900. Chase, to figure out when they're going to have the same population, what can I do with those equations? Just like the chubby bunny kitty method. What did we do with the chubby bunny and the kitties equations?
Minus the smaller one.
I can't do anything yet. You're skipping step 1.
Oh, yeah.
We first took the bunny and the kitty, and we did what with them? We put them... Equals. I was just trying to be silly. Guys, You have to start by putting them equal. This is, if you check your notes, and don't do it now, but Schoology is always there, it's the equal values method. We nicknamed it Chubby Bunny Kitty because that's the problem CPM uses to teach it, and it's kind of funny. But this is the equal values method. I want to take those two equations, put them equal to each other, and then solve. I'm going to copy these and just do what is easier for me because I can copy paste. Good thing we're going to do it together. Well, if I look at the x's first, do you want to subtract 22x or add 15x?
Add 15x.
Why?
Because
It was a 50-50 shot. So I mean, you got to tell me why. Lydia and everyone, here's why we think about the x's first. If I would end up subtracting 22x, I would end up with negative 37x over here. We don't want a negative x value. That makes things more complicated. So by looking at the x's first, Will said we can add 15x to both sides, and whether he realized it or not, that's the best method because it keeps things positive. It's not right versus wrong. It's avoiding trapdoors. You could do it the other way and still get it right. It's just more difficult. I'm trying to make your life easier because math is already hard. So when we do that, 1160, now we have positive 37x. By the way, happy holidays. Now that Halloween is over. So, for real, that is going to make me wait until I know that you're comfortable in what we're doing right now. So, to back this train up and make sure we all know what we've jumped on board, we wrote an equation for both high schools. Is everyone comfortable with how we got our two equations for the high schools? We know what we started with. We know how we're changing. Questions about that? How we got P of X and R of X. We chose P and R for Post Falls and Richmond. You can use whatever you want, honestly. Then, we set them equal to each other, because what we're trying to answer is when are their populations equal? X on both of them represents years. Question. Then we start doing whatever we want on both sides, because it's algebra. And we can do whatever we want. There is a better option and a not so better option. This is the better option. Now that we've added 15x to both sides, Kira's not here. Hello, Kira, if you watch the video from home. Jack, what do I do now?
Minus 1,160 from both sides.
Yep. Because now that the x's have claimed the left side, right? This is the only x that we have, so it essentially said we've got the left side. So get out of here constant numbers. So minus 1160, 37x equals 740.
Yeah.
Questions on how we got there? Now, Nolan, what do we want to do to finish this off? Divide by 37. On both sides. Why? No, that's a lie. Try again. Then ask a question. What don't you understand about what we just did? So that's not really P times X. So let's, guys, for real, I will not let you get away with saying you don't know what you're doing. Because, if that's for real, that's my job. This is not really P times X. We say this You might want to make a note on your graph paper. We say this P, I'm going to put quotes here, P of X. It's the value of P, post-falls, they're people, right? Because that's what we're talking about, as X changes. X is our input into the function. We're only using that because we can't use Y equals for everything. We've got multiple equations. So that's post-falls' student population as the years change. P of X. Does that make more sense now? What else? You said you're cooked. You can't be cooked with one thing.
What does the 22x represent in the top question?
You look at the details we had and tell me if you can figure out what it represented.
This is adding 22 students per year, and x is the year.
Lydia.
How do I figure out what the population is after 20 years?
So once we do this division, so hold on, we were trying to figure out, make sure everyone's good with how we got down here. Are you feeling better now? At least a little bit. Guys, this is why you got to do your homework. Because you practice, I'm guessing you got 20 here. I'm guessing you got 20, yeah. Guys, I know, like, I get it. You're 12, 13, whatever. You think you know better. It's fine. Sometimes you do. You are smarter than me. But if you don't try something on your own, like if you only ever watch videos of somebody riding a bike, do you know how to ride a bike? No. You have to try it on your own, or you don't know what you can or cannot do. When you try to ride that bike and fall over, there's your feedback. Are you done riding a bike forever because you fell over once? No. You get back on that bike, and you get motivated, and you say, I'm going to figure this out. I need to keep pedaling. I need to, what you're doing is unnecessary. I need to keep pedaling. I need to, like, sit up, like, whatever. That's why we practice this on our own. So now that we got our x of 20, which we said that is actually solving years. Sorry, Lydia, you were saying.
How do I figure out what population they have?
You tell me. How did we figure out how fat or how chubby the kitty and the bunny were?
I don't remember.
Check what you wrote down. So this is why my homework always involves examples from class. Well, not always, but most of the time. If you had drawn what I drew here, what did we do with the x after we found it in the Chubby Bunny Kitty problem, Madeline? We plugged it back into either or both, really, of these equations to figure out what the y came out to be. So if you have that written down, you should be able to look back to it to say, oh. So all we do is take the x, plug it back into one of these equations. Okay, so I like positive better. I'm going to use that one. 1160 plus 22x. 1160 plus 22x. And that was p of x, I think. But now, that's p of 20. Because x is 20. So now we make this p of 20 at 440.
Yeah.
All my pens are gone. Try to see if unplugging and replugging in fixes Dave. I can't do it right now. It'll screw up my mic. And how many students is their population when they are equal? There we go. If you plug it into your other equation, you should get the same answer all over again. You should get 1,600 from Richmond as well. Questions? Grab your other handout paper real quick because we're just going to look at it for a moment. Because I know I only got 4 minutes left. Yeah, I know. Time flies when we're having fun doing math.
You have a lot of fun. Just a little. We don't have 4 minutes. Sometimes I have a lot of fun.
We have 3 now that we've been arguing for a minute. We have 3 minutes left.
See,
You know what actually
Did I give this away?
by solving the actual equation. So when you know what actually
All right, so hold up. Notice that this paper is completely practice work, and I stole this back from Will. But that means everything on here is practice work, which means we might spend some time on it together, but let's look at one more problem together, especially talking like science fair. We're going to compare the growth of two plants. Plant A, 4 inches tall, currently, this is nowhere. So this is from 524, but that's why I said all of that paper's practice work. This is nowhere. Like, aside from
It's
up
not
here.
on the paper.
Correct.
Okay,
That is all practice work.
Trying to find it.
So, like, I hope to give you a minute to set up the next problem. That's after we talk about this one. Guys, we're not even going to do this problem. We're just going to talk about it for a second. So if you're frantically writing, stop, chill, take a breath. Plant B starts at 9 inches, but is only growing ½ an inch per day. Which is more? Half or 2/3? 2/3. So eventually, the 2/3 of an inch per day will catch up. So if I write down plant A's equation and plant B's equation, any questions on how I would write those down? My growth rate, my initial. My growth rate, my initial. Questions? Then I want to know. Stop. Just like everyone stop. Just be up here with me. Stop what you're doing because you're distracted. Because here's where the rubber hits the road and things get more difficult. If I set them equal to each other, ignore the red writing right now. I just put plant A equal to plant B. I just wrote them in white instead of the colors. Now I have a division by 3 and a division by 2. How could I take care of a division by 3 and a division by 2 at the same time? Well, it's already up here. You guys are funny for raising your hands. Just shout it out. Times 6. So I would have gotten 12 divided by 3 or 4x. 6 times 4, 24. 6 times a half, 3, or 6 over 2. 6 times 9, 54. Questions on why I did that? Pardon?
So, when you like first taught us
Yeah, fraction buster.
fractions, I thought like when you like multiplied the denominators, you replaced the numerator with the number that you got.
I mean, if you work a little slower, you can like do the math and write it out. You don't just replace things. You have to do the multiplication. Yeah. So then I start doing. Now, guys, I could have just worked with the fractions, but they're kind of annoying. And 2/3 is a repeating decimal, so decimals is not a good option here. I start doing the algebra. I figure out my answer, and once I know my x, I can plug it back in. So just like that, Nolan, do you know if you're leaving?
I think this is just
So you might want to take your stuff, though, because we're heading to lunch. Just like that. Hey, friends, I'm going to help you with this real quick. I know it's time to go to lunch. But, guys, just like that, if you have two equations that are y equals, well, y should equal y, right? Shouldn't y equal itself? So we could start this by doing negative x plus 8 equal to x minus 2, because we want y to be equal to y. Y should be equal to y, right? We should at least be able to make them equal, and then we solve that. All right, have a great day. Thank you. Bro, do you think I wanted to get sick? I started feeling crummy on Friday, but pushed through. Saturday was like meh, but then I didn't sleep Saturday into Sunday well at all. Sunday into Monday was terrible.